No man-made object has ever come closer to the Sun before. The Parker Solar Probe will provide unique measurement data about our star, but for all the excitement about this project, people are moved by one question. So why does the probe not melt when it's fairly close to the Sun? And by no means is that the surface of the Sun. In fact, the Parker Solar Probe regularly stays in the hottest layer of the Sun. Back around the Sun, it's hottest in what is called a corona. In this video, we'll take a look at how the solar probe is enduring the heat and what new insights it will give us. Before we begin, we want to ask you to contribute something very important to our channel when you leave us a comment at the end that fits the topic. From now on, whenever we award a heart as a reward for a contribution on our part, we will always reward one for their contribution. We will also pin your interesting and enriching contribution at the top for everyone to read first. Just be sure to do that with the video and make sure you already have a subscription, and mention both at the top of your comment. For us Earthlings, the journey to the Sun is important to us, and it's foremost on my mind. Without the Sun, there was and is no life on our planet. Solar radiation is the reason why we have climate and seasons. The magnetic field of our planet is constantly influenced by the activities of the Sun, and some even suggest that solar storms exert quite confounding influences on the human psyche, much like the full moon. From the strictly scientific point of view, astronomers and cosmologists would especially like to know more about the yet mysterious processes on the surface and in the corona of the Sun. Corona means wreath. You can only see this thin glimmer around our Sun from Earth with special filters or during a solar eclipse. Until today, scientists don't know what is the corona, and after all, in that layer, which is several kilometers above the surface of the Sun, temperatures reach temperatures up to 1 million degrees Celsius, while the temperatures on the surface of the Sun barely reach 6,000 degrees Celsius. Like its corona, the Sun isn't uniformly hot all over its surface. Mergers are constant, things are bubbling up, forces are swelling around. Only there, the heat is in the form of the finest particle, clouds, as it is in the corona. These cloud evaporations are directly caused by the activity of the Sun's surface. The particles making up the corona are made by the fiery processes on the Sun, or at least are affected by them. But these connections are not well understood, and that's the work of the Parker Solar Probe to learn more about these connections. The cause of the extreme heat formation is something behind the effect, as must be physical forces, and probably also chemical processes of which we know nothing as yet. And perhaps there are lessons to be learned for our own energy industry from the probe's findings. Just imagine that in the case of the electricity you draw out of a wall socket, it has always been generated through heat. The point is, if we could also generate temperatures or heat the way the Sun does, then maybe we could produce large volumes of energy much easier, or just multiply energy in a simple way, and perhaps more environmentally. The probe, of course, is also studying the famous solar storms, and in addition it's studying the enormous heat produced in the corona. This is gigantic particle eruption. The winds come from violent eruptions on the surface. These eruptions release plasma and particle streams, which first waft around the immediate vicinity of the Sun, before the charges make their way into the corona and escape the Sun's gravitational hold through a mechanism that we still do not know about. 3 years later, having drifted away from the Sun at extreme speed, these particle streams scatter in all directions into space. If these particle streams hit the magnetic field of the Earth, that is very shifted and stretched. If such very powerful solar winds reach a certain strength, they can be assumed to override the whole of earthly electricity, according to experts. Nearly 100 years ago, we have intensely researched solar flares and winds. That was enough to make out some of the rhythms in the winds and the eruptions. Normally, the Sun has the 11-year rhythm. In fact, the eruptions take place within certain pattern in this time. We knew the winds pretty pinpoint predictable for a while, but then all of a sudden the sun changed its behavior. The activity meanwhile seemed to start and then weaken in an unusual way. Then, suddenly, solar activity rose. Again, and scientists were already worried. The complete outside of all of these cycles, known so far. We don't know when the sun is particularly whimsical, and probably not of benefit for an increasingly technological world in general, which means we can't be sure so far on Earth. And we need to know more about the sun. To lose all power for a month or so would cause a great disruption to life and civilization on the planet, but a total loss of electricity would plunge the planet into indescribable chaos within hours. In many ways, the Parker Solar Probe has an enormously important scientific mission. In August 2018, the Parker Solar Probe was launched, but NASA is working with ESA and several other nations to launch the solar probe. When it came time to launch the probe, NASA was lucky that the Sun and Earth were especially close, and that the probe's trajectory was perfect. Parker Solar Probe couldn't just head straight for the Sun. Probes can only move along the gravitational fields of planets, and the force of each further flight is spent on the onward flight, and the probe made 7 laps around Venus to take off for the Sun. Those flybys of Venus also gave NASA a few new impressions of Venus itself, of course. In April 2021, the time had come. The probe flew through the glowing hot corona of the Sun for the first time. Now you can know how it achieved that. The probe flew past within 6.1 million kilometers of the Sun's surface during its flight. Outside were temperatures of 2,500 degrees Celsius. But inside the probe, the sensitive measuring instruments were kept well under 30 degrees Celsius. For nearly 10 years, international teams of scientists, engineers, and technicians tinkered with this masterpiece. A thermal protection system that includes special materials, a heat shield, the probe's position, and that uses a water-powered cooling system is key to the probe's success. The water cooling system was built by the Hopkins Applied Physics Lab in Maryland, USA. The highest temperature thermal protection system is made from 2 layers of carbon fiber reinforced carbon, retaining its structural properties even at the hottest. The carbon foam sits between these layers also. These fibers have such big air pockets on the inside that they hardly even transfer any heat on the outside. All of the Parker Solar Probe's white aluminum oxide encasing. The material and color reflect light in the best way, which means a material and color that reflect more of the heat rather than absorbing it. There is a layer of tungsten between the carbon and the aluminum oxide. This almost white, very dense, heavy metal only boils at a heat of 5,900 Kelvin. As the tungsten layer separates from the probe's outer skin and carbon layers within the probe, the outer skin and carbon layers inside the probe almost do not react to each other. The heat stays outside. Even in the Sun's extreme corona, the position and trajectory of the probe is programmed to position the shield towards the surface of the Sun at all times. On Parker Solar Probe, cameras and measurement sensors have been placed so that they poke out from behind protective shields about as far as they can without looking straight at the Sun. On its next flights, the Parker Solar Probe will only fly through the outer layers of the corona and for a short time. The amount of hot particles with which the probe comes into contact in these outer layers is very small. The heat transfer will further reach an acceptable minimum. If you literally can, you can regard the flight of the probe through the extreme temperatures as dipping your hand into a hot oven. If your hand stays in the oven for only a short time, you won't get burned as long as you don't touch the metals or any heated food in the oven. In particular, the Parker Solar Probe's fly-through times are chosen to match close to a dwell time in the oven. Even on its first pass, the probe, which was perfectly equipped with superb instruments, the scientists and engineers breathed a sigh of relief when the Parker probe stayed fully operational on April 28, 2021, at temperatures approaching 3,000 degrees C. It was a wonderful feeling for all the NASA and all the agencies involved. It reached a speed of 586,000 kilometers per h, flew through the corona at brief first measurements, filmed a stream of particles, and quickly left after only a few hours. It also periodically approaches the Sun far from the Sun, so that during the times it was far from the Sun, it goes past Venus or Mercury. But of course, the scientists would love to spend a little more time with these two planets closest to the Sun. Moreover, during these same intervals, the probe resumes using the gravitational force of Venus to increase speed and propel it toward the Sun with renewed vigor. We won't see the next approach to our star until 2024. This exceptional mission will take quite a while for the scientists, but it will be worth it. They are already unique first results for researchers, and the evaluation of the measured data will take several months. On December 24, 2024, of all days, the probe will probably come closest to the Sun. It will be truly Christmas for the researchers. The unique measurement data and images are a gift for them to look forward to. Until then, a total of 5 approaches are taking place, with the 5th finalized in July 2025. But of course, everybody on Earth wants the probe's design to make it through all of the fly-throughs. Never mind that. Researchers and technicians don't expect the probe to work beyond summer 2025. Once the mission is scheduled, the Parker probe can be extended at any time as long as the Parker probe is still functional. But that should be more than enough flybys to deliver exactly the sort of solar data that solar researchers need to make important discoveries about our star. The data will allow us for the first time to know what is really happening on the surface of the seething star, what solar winds look like around the Sun, and, of course, what processes make the Sun emit its radiation during different cycles. Named after U.S. scientist Eugene Parker, the probe. Parker is a solar exploration pioneer, and he coined the term solar wind.